Hello students, in this video we are going to study about refraction through a prism, but before that we should know what is a prism. So here I am showing you the diagram that is of a prism, and a prism is a wedge shaped portion of a transparent refracting medium. So it is basically made up of a transparent refracting medium and of a wedge shaped, means triangular cross section होता है इसका, and it is bounded by two plane faces inclined to each other at a certain angle, right? So there are two faces here. The two faces are ADFCA and ADEBA. So these are two rectangular faces which are inclined to each other at a certain angle, and these faces are called refracting faces of the prism. So we can define a prism as a wedge shaped portion of a transparent, it should be transparent, of a transparent refracting medium bounded by two plane surfaces, plane faces inclined to each other at some angle or at a certain angle. This angle A on which these two faces inclined is called angle of the prism. So the faces or the inclined faces A, B, E, D and A, C, F, D, these inclined faces are called refracting faces of the prism, right? And the angle A at which these two faces inclined, this angle A is called angle of the prism, and the third face named as BEFC. The third face BEFC, that is opposite to the refracting edge. This line is called refracting edge, the line AD along which the two refracting surfaces meet is called the refracting edge, and the plane that is opposite to this refracting edge is called base of the prism. So the face BEFC is called base of the prism, and the line AD is called refracting edge. So the line at which the two faces, the two inclined faces meet is called refracting edge. The plane or the face which is opposite to this line AD is called base of the prism, and the two faces inclined at some angle, here it is shown by angle A, this is called angle of the prism, and the inclined faces are called refracting faces. So this is the prism. Now the section of the prism, if we cut a section of the prism such that it is a plane perpendicular to the refracting edge, then this section is called principal section of the prism. For example, this plane ABC. So if we cut a plane perpendicular to this refracting edge, just like plane ABC, then that section of the prism is called principal section. So we can define principal section as any section of the prism cut by a plane perpendicular to the refracting edge is called principal section of the prism. So this is all about the prism. Now we have to move to the refraction through a prism, or how the light get deviated from the prism, or what deviation this prism produced when placed in the path of the ray of light. Okay, so now we have to show the diagram for the deviation produced by a prism. So to show the refraction through a prism or deviation produced by a prism, we take the principal section A, B, C of the prism. A ray PQ, this ray PQ is incident on the face AB, right? This is the incident ray, and this ray enters the prism, or we can say it is entering the denser medium. For example, it can be glass. If this prism is made of glass, then the ray is entering into the glass, and since it is moving from rarer to denser medium, it will move towards the normal, and the normal is shown by this dotted line. So actually path of the ray PQ was like this, but it bends towards the normal. Okay, the ray PQ after entering the prism, after entering the denser medium, bend towards the normal. That means angle I is greater than angle R in this case, and we get the ray QR. PQ after deviation give us the ray QR, and this ray QR again hit the surface AC then and undergo refraction once again. So the ray QR suffer another refraction at the face AC. This time after refraction, or because of refraction, it is moving from denser to rarer medium. So actually if this is of glass, if prism is made of glass, then the ray is moving from glass to air. So the light ray is moving from denser to rarer medium. That's why it bent away from the normal. So the ray QR, when incident on the face AC, it should go like this. Okay, the ray QR should go like this, but it bends away from the normal. So angle I dash, which is the angle of refraction for the ray QR, and emergent angle for the ray PQ, this I dash is greater than R dash, since the ray is bending away from the normal. Now the angle of deviation, एंगल ऑफ डेविएशन को हम कैसे डिफाइन करेंगे? द इंसिडेंट रे इज पी क्यू एंड द फाइनल इमर्जेंट रे इज आर एस. So initial ray we have was PQ, which was going along this path, but the final output, or the final ray, or the emergent ray that we get, it is along this direction. It is in the direction of RS. So basically this was our initial ray, which now bends to this direction. So the change in the direction of the path of light, that is angle delta, this is called deviation, or this angle is known as angle of deviation. So we can define angle of deviation as the angle between the incident ray and the emergent ray, the direction of emergent ray, and it is denoted by delta. So here I am writing the definition of angle of deviation. Angle of deviation delta can be defined as the angle between incident ray, angle between incident ray and emergent ray is called angle of deviation. Now if I and R be the angle of incidence and angle of refraction at the surface AB, and we let R dash and I dash be the angle of incidence and angle of emergence at the face AC. So face AB per incidence is I, refraction is R. For face AC, our angle of incidence is R dash, because light is incident by the angle R dash, and this time we have angle of emergence. Angle of refraction is I dash, but it actually work as the angle of emergence, so we denote it as A dash. This is for face AC. Now A be the angle of the prism as per the diagram. If this is the principal section, we are assuming that capital A be the angle of prism on which both the inclined faces meet. Then from the quadrilateral, A, Q and R. So we are talking in quadrilateral A, Q and R. Let's see in the diagram, this is A, Q and R. In this quadrilateral, angle A plus angle Q and R, these are the opposite angle, their sum should be 180 degree. So in quadrilateral A, Q and R, angle A, which is angle of prism, plus angle Q and R is equal to 180 degree. This is equation number 1. Also from triangle QNR, if we see this triangle only, from triangle QNR, by applying angle sum property, we can write that R plus R dash plus angle QNR is equal to 180 degree. So angle QNR plus R dash is equal to 180 degree. This is equation number 2. And from these two equations, we conclude that this value R plus R dash is actually equal to angle A. So from equation 1 and 2, what we get is angle A is equal to R plus R dash. Let it be equation number 3rd. Means angle of prism is equal to the sum of angles R and R dash. Now from the triangle MQR, in this triangle MQR, our task is to find the angle of deviation to get कि वो जो लाइट हमने इंसिडेंट किया था, द इंसिडेंट लाइट पी क्यू, हाउ मच पाथ और हाउ मच इट गेट डेविएटेड, उसके पाथ में कितने एंगल का डेविएशन आया, दैट वी वांट टू नो. मीन्स वी एक्चुअली वांट टू फाइंड डेल्टा. आवर टास्क इज टू फाइंड द वैल्यू ऑफ डेल्टा. So for delta we have to move to triangle MQR. Now we are moving to triangle MQR. So in triangle MQR, what we have, by applying exterior angle property, this delta angle is the sum of these two angles, means MQR and MRQ. So we can write delta is equal to angle, the sum of MQR, angle MQR plus angle MRQ. Now we can write angle MQR as I minus R. If we see the angle, these rays are cutting each other, these lines are crossing each other, and these two angles are vertically opposite angle. So whole angle MQN is I. This is I because these are vertically opposite angle, and we just want this section. So this section will be I minus R. Means MQR की जगह we can put the value I minus R. Similarly, in the place of MRQ here, we can write I dash minus R dash because these are vertically opposite angles. So we can write them as I dash minus R dash, means delta or angle of deviation is equal to I minus R plus I dash minus R dash, or we can rearrange it to I plus I dash minus R plus R dash, right? I plus I dash minus R plus R dash. And from equation number 3rd, we know that this value R plus R dash is capital A, that is angle of prism. So we can write delta is equal to I plus I dash minus A, or we can write it as I plus I dash is equal to delta plus A. That means this is angle of incidence, right? I dash is angle of emergence, delta is angle of deviation, and A is angle of prism. So the relation we get is angle of incidence plus angle of emergence is equal to the angle of prism plus angle of deviation. So when a ray of light is refracted through a prism, sum of the angle of incidence and angle of emergence is equal to the sum of angle of deviation and angle of prism. And if we know these values of I dash and A, we can find the angle of deviation or the deviation produced by a prism. Now let's see what are the factors on which this value of delta depends. So the factors on which angle of deviation delta depends are, first factor is angle of incidence, that at how much angle the light is incident, because it also coming in the formula. So delta will be affected by the value of I. Second thing, it will be affected by the angle of prism, right? Angle of prism and angle of incidence affect the value of delta. Third thing is the material of the prism. Material of the prism also affects the deviation produced by it. Third factor is the material of the prism, and the fourth and the last factor is the wavelength of light used. For different light it will give different deviation. So wavelength of light used also affect the value of angle of deviation. Now if we plot a curve between angle of deviation and angle of incidence, then we get a graph. Initially when we increase the value of angle of incidence, angle of deviation decreases, it achieves a minimum value, and beyond that point it again starts to increase. I am showing you the graph. So if we trace a graph between angle of deviation and the angle of incidence, we get a curve like this, and it shows that as the angle of incidence I increases, the angle of deviation, means delta, first decreases, right? First it decreases and attains a minimum value delta m at a certain value of I. At a certain value of I, it attain the minimum value of angle of deviation, and after that point it again starts to increase. Now except this point, at all other points we can see that for all the values of delta, there corresponds two values of I, means for every value of delta there are 2 points for which we get the same value of delta. This shows that because of the symmetry of I and I dash in this equation, if we interchange their values, it won't affect this formula. Means if I is, for example, if I is 2 and I dash is 5, or if I is 5 and I dash is 2, it will give us the same answer. That means there is a symmetry between I and I dash in this equation, which shows that if we interchange the values of I and I dash, it won't affect the value of delta. And physically it means the path of ray can be traced back, which give us the same angle of deviation, right? So ray can trace its path back, resulting in the same angle of deviation, and the minimum value of angle of deviation suffered by a ray on passing through the prism is called the minimum deviation or angle of minimum deviation, and it is shown by delta m. So angle of minimum deviation is angle of minimum deviation is the minimum value of angle of deviation, means the minimum value of delta suffered by a ray on passing through the prism. This is called angle of deviation. As we said that अभी कि जो आपका एंगल ऑफ मिनिमम डेविएशन है या एंगल ऑफ डेविएशन है, it depends on the material of the medium. That means it will be affected by the change in refractive index. So there must be some relation between refractive index and angle of deviation or angle of minimum deviation. So our next task is to find the relation between refractive index of the material of the prism and angle of minimum deviation. So when a prism is in the position of minimum deviation, we are considering the case of minimum deviation. That means when delta is equal to delta m, at such situation I is equal to I dash. Okay, when a prism is in the position of minimum deviation, the ray of light passes symmetrically through the prism, and in that case I is equal to I dash and R is equal to R dash. So the formula here we have this formula, delta is equal to I plus I dash is equal to minus A, delta is equal to I plus I dash minus A. In it we can put I dash is equal to I and delta is equal to delta m. So in this equation, if I dash is equal to I, delta will be equal to delta m. So I can write it as delta m is equal to I plus I minus a, or a plus delta m is equal to 2I, or I is equal to a plus delta m upon 2. Similarly, we know that a is equal to r plus r dash, that we have proved earlier, and in this case, for this particular case, r is equal to r dash. That means we can write it as r plus r or 2r, which shows r is equal to a by 2. So we have I and r, and now we are going to find refractive index by using Snell's law. So from Snell's law, we know that the refractive index of the material of the prism mu is equal to, since it is placed in air, so we are considering that mu1 is air and mu2 is glass or the material of the prism, and we are writing it as mu. So the refractive index of the material of prism mu is equal to sine I upon sine r, and we are going to substitute these values here. So mu is equal to sine a plus delta m upon 2 upon sine a by 2. So this is the relation between the refractive index and delta m, or minimum value of angle of deviation, or we can say that angle of minimum deviation. And by knowing or measuring the values of a and delta m, we can find the refractive index mu of the material of the prism. So if we use a spectrometer and find the angle of prism A and the angle of minimum deviation delta m, then we can find the refractive index of the material of the prism. This is the relation between mu and delta m. Now if the prism has a small angle, means angle of prism is small, or we can say A is very small. If the prism we are using is of small angle, means the value of A is less, and the light that we are incidenting, that is also at a small angle, means the light is incident at a small angle I, or the value of I is small. In that case, the values of other angles, means the values of r, r dash and I dash, will also be small. And if it is so, then in that case we can write the sine of these angles equal to the value of the angle only. Means for small angles, sine theta is approximately is equal to theta. This we are going to use. So here, by using Snell's law for the refraction at the face AB, for the face AB we had mu is equal to sine I upon sine r, and now if these values are small, so we can write it as I upon r, or I is equal to mu r. This is the relation we get for the face AB. Now for the face AC, we have mu is equal to sine I dash upon sine r dash, and it is equal to I dash upon r dash. So we get mu is equal to I dash upon r dash, or I dash is equal to mu r dash. These are the two relations we get for the assumption when the angle of incidence is small. Hence the deviation produced by this small angled prism, we know that delta is equal to hota hai I plus I dash minus a, and for such prism the values of I and I dash we already have. We are going to substitute these values in this equation. So for the deviation produced by the prism delta, we have I is placed per mu r plus mu r dash minus a, or by taking mu common we get mu into r plus r dash minus a. Now r plus r dash is again a, so we can write delta is equal to mu a minus a, or by taking a common we get delta is equal to mu minus 1 into a. This is the required deviation produced by a small angled prism. So delta is the deviation produced by small angled prism, and it is equal to mu minus 1 capital A. That means it doesn't depend on the angle of incidence, it depends on the angle of prism A and the refractive index of the material. So for small angled prism, the angle of deviation depends on the refractive index of the material as well as the angle of prism. It doesn't depend on I, R or any other angle, right? So that's all about the refraction through a prism that we covered all about the refraction through a prism, deviation, angle of minimum deviation, right? All the relations between all these factors. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.